Okay, my voice is audible. Okay. Okay, we'll start it. So in morning lecture, we can give the brief idea of unit number 3. So what are to study in image enhancement, and what are the different classification or different techniques of image enhancement, right? So update, we can study the fundamental concepts of image processing, as well as how we can transfer the information from one domain into the another domain. So that concept we can study by using image transform. So we can transform the information from a spatial domain into the frequency domain, as well as the from frequency domain to the time domain by using various types of transforms. Okay, so as we have to study the different techniques of image enhancement, first we need to understand basically what is our image enhancement. Okay, so in a simple language, we can define the definition of image enhancement. So the image enhancement nothing but improve the quality of input image. Okay, and that can be used for a specific applications. Now, in this definition, the specific application is important word, because we can use the image enhancement in a number of applications. So depending on the applications, we can use the number of techniques. So if I were to use the image enhancement in our healthcare system, yeah, if I were to use the image enhancement to improve the simply quality of input image. So as we take the example of our newspaper. Okay, so in newspaper also we can find out the number of images. Some images might be in a black and white, some images are in a color, right? So in newspaper industry also we can use the image enhancement. So if we observe a newspaper, so in a newspaper there is a some pages are also printing pages. So on that pages the image quality should be better as compared to another color images. Okay, so if we compare the normal print paper and color print paper, so based on these two paper also we can get the idea how the quality of image can be distinguished. Okay, so by using image enhancement we can also improve the quality of images. So in newspaper industry also the image enhancement can be used. So basically what we need for the image enhancement technique, so in order to achieve our goal, yeah, in order to enhance the quality of input image, first we require the input image, right? Means we have to improve the quality of input image, right? Suppose if we take the example of amplifier circuit. So in amplifier circuit, first we need the input signal. So based on the input signal, the amplifier can amplify the uh, whatever the input. So if we provide the sound as an input to the mic, so the mic can amplify the intensity of sound. So similarly, in our image processing also, if we have to improve the quality of any object, so that object we have to consider as an input. So here we can consider input as an image, right? Because we can deal with only the various types of images. Okay, so the image part is different and video part is different. So while improving the quality of images by using such image enhancement technique, we have to consider input as an image. Okay, so that input image might be a color image, black and white image, grayscale image. Okay, so it might be a in any format. Okay, so for basically, yeah, for general use we can use color images. Okay, so why we can use only color images? So as we okay, wait 1 minute. Just wait a minute. Okay. Okay. So what we discuss here? हॅलो. काय डिस्कस करतो आपण? ऐकते का सगळे? Okay. So as we use the image enhancement technique, we can take a input as an image. So that input image might be in any format. So based on the input image, we can apply the number of techniques, and by using number of techniques, we can improve the quality of input image. Okay, so it is called as a image enhancement. So now in order to achieve the image enhancement, we can use different methods. So generally there are two methods. Okay, my voice is audible? Yes, it's clear. Okay, so generally in image enhancement there are two methods. One is a spatial domain method and another is a frequency domain method. Now what is a spatial domain method? So in spatial domain method we cannot apply any transform techniques. Okay, so we can deal with whatever the analog pixels, so we can deal with only the pixel values. Okay, and in frequency domain we can use various types of transforms. It may be a Fourier transform, cosine transform. Okay, and in some cases we can use both the methods. So we have to study what is a spatial domain method, what is a frequency domain method, and what are the types of these two methods. Okay, so just keep in mind we have to study this type of two methods in a image enhancement. Okay. Uh, okay, so we'll take a simple example of image enhancement. So how the quality of image can be improved, how we can say that the input image having a better quality as compared to output image. So here we can take one example of noisy image. So it consists of various dots. So if we observe carefully, it consists of number of dots. So due to this, the image is uh, not able to visualize clearly. Okay, so this is a one type of noise. So we have also studied the different types of noises. Okay, so if we observe any one photograph, yeah, we can also observe our passport size photo. Okay, yeah, id size photo. So on that photo, if we identify a small number of dots, so it may be a white dot, it may be a black dot. Okay, so this is a one type of noise. Okay, so if we take a one photo by using our mobile camera, if we take a printout of that photo, then we can observe various types of dots on a printout pages. Okay, so that small number of dots is called as a salt and pepper noise. Okay, so it is a one type of noise. So along with this, there are a number of noises that we have to study in an image degradation model. Okay. So if we take the, yeah, if we consider the noisy image as an input, and we can apply certain filters by using by using the image enhancement technique, so we can remove such type of noises from the input image. Okay, so finally we'll get the output image, and we can say that it is a denoised image. So we can remove the noise which is present from the input image. That output image is called denoised. Okay. So by using image enhancement, we can also remove such type of noises. So here also we can get an idea. So if we observe the two images carefully, so the second one, that is a denoised image having a better quality as compared to noisy image. Okay, have you observed it?
दोन्ही सेम दिसते सर.
Yes. Yes, any doubt? Hello. Okay, so along with removal of noise, so the image enhancement can also perform various types of operations. Likewise, we can increase the brightness. Yeah, if I have to make a image too bright, yeah, if I have to make an image too dark, so that is nothing but the contrast adjustment. Okay, so if we make an image bright, yeah, if we make an image dark, okay, so that concept is called as a contrast adjustment. So in image processing, when we bright the image or when we more dark the image, that concept is called as a contrast adjustment. So depending on our requirement, we can also change the brightness of image. So to increase and to decrease the brightness of image, so that concept is called as a contrast adjustment. Okay, so if we observe this slide, so here we can take the three examples. One is a low contrast, second one is a medium contrast, that is called as a original image, and third one is a high contrast. Okay, so in this case we can improve the brightness, and in first case we can decrease the brightness. So if we increase the brightness, so the image will be look too bright, so that is called as a high contrast. And if we decrease the sum of brightness, the image will be look dark as compared to the original image, that is called as a low contrast. Okay, so have you get it? What is a low contrast, medium contrast, and high contrast? Okay, so by observing this image we can get the idea. So if we improve the brightness of the image, so that is called as the improvement of contrastness, and if we decrease the brightness, so that is referred as a low contrast. So by using this image enhancement technique, we can also remove the noises, and we can also improve the brightness or decrease the brightness also. Okay, so along with this, also we can perform a number of operations by using this image enhancement technique. So all that thing we have to study in a image enhancement. Okay, so now what is the basic objective to study the image enhancement? So fine, we need to study image enhancement. So as we discussed in the earlier lecture also, if we have to make the object more clear, so if any one object is not able to visualize properly, then we can apply certain techniques, and by using such technique, we can improve the quality of that object. Okay, so if we take a one picture by using a mobile camera, so in order to make some changes in that picture, we can apply some colors, we can apply uh, some contrast, we can we can increase brightness, right? We can change various shades. It may be a black and white, it may be a color. We can add various types of effects in our image also, right? So that nothing but the image enhancement. Okay, so what are the techniques that are used to help to improve the quality of input is nothing but the image enhancement. So to achieve this kind of applications, we have to study the image enhancement. So the basic object of image enhancement is that simply we have to improve the quality of input things, yeah, quality of input images. So as we deal with only images, so we have to consider image enhancement. Then, as we discuss also, there are two types of processing. One is called as a point processing, and other is called as a neighborhood processing. Okay, so these two type of processing we have to study in a image enhancement. So basically, there are two techniques to study this type of two processing. One is a spatial domain method, and another is a frequency domain method. Okay, so here in a 1 minute we can discuss what is a spatial domain method. Okay, so as we consider the image consists of number of pixels. Okay, so if we take a one image and we can consider the size of image is a 256 by 256, then it consists of 256 rows and 256 columns. So it having some pixels in a x coordinate and some pixel in a y coordinate. Okay, so we can consider this as a function of xy. So it is our original image, yeah, our input image. So always the input image can be represented with the two coordinates, there is a x coordinate and a y coordinate, and it can be represented by a f of xy. So always we can represent any image in this manner. So the input image can be represented as a f of xy. Now we have to apply the method in order to improve the quality of image, yeah, in order to change the position of various pixels. So we can call as a various operators. So here we can use the t as a one operator. So it may be any operators. So we can use a various image transforms. We can use various enhancement techniques. We can use various compression techniques. Okay, so any operations can be represented as a operator. Here we can mention a notation as a t. So here t is a operator. Okay, so that can be performed on an input image. Okay, so if we perform any operation on input image, we'll get a image at the output side. Okay, so that image we can represent it by a g of xy. So why we can represent in a g of xy? Because if we apply any operator on an image, so there is some change in the input image. So the original image will be not look like as it is. So if we apply some operations on the image, obviously there is a change in its pixel values. Okay, so that change in pixel values can be represented by a function g. So the changed image or after processing image that we can call as a processed image can be represented by a g of xy. Okay, so here we can represent the image by using g of xy is equal to t f of xy, means the processed image can be obtained by applying the any operator on an input image. Okay, so in a spatial domain method we can apply any techniques to improve the quality of input image. Okay, here we can take a one example. So here we can consider a one image. Okay, so it might be a any array, right? It may be a 3 by 3, 8 by 8, 256 by 256. Okay, here we can compare the input image and enhance the image. So here we can compare one rectangle. So that image can be subdivided into the number of rows and number of columns. Okay, so if we have to apply any operator on it, so that operator can be represented as a T. Okay, so after applying the operator, okay, so if we compare the particular part of the image, so while we can divide this image into the number of rows and number of columns. Okay, so in order to identify the change in image, so there is a one input image, and we can apply one transform on that image, where we can apply one operator on an image, and we can compare the one by one box. Okay, so if we consider the first row and first column of the input image and enhanced image, so there is a change in pixel values. Okay, so by using this we can compare the change in input image. So how the position of pixel can be changed. So if we increase the brightness, so it is a change in input pixels. If we decrease the brightness, what is the change in input pixels. So that we have to compare here. So that's why we can take a one random image, and that image we can divide into the number of rows and number of columns, and after applying the any operator we can compare the one by one box. Okay, so based on this we can consider the change in input image. Okay, understood it? समझते का? Hello. Yes, have you understood it? Any difficulty? Okay. So here we have to study the various types of operations. So that is called as a point processing. So we have to study the two types of processing. One is a point processing and another is a neighborhood processing. So we have to study what is a point processing and what are the different types of point processing. So in point processing, we can deal with a particular pixel values. So as there is a number of rows and number of columns, so if we have to find out the particular position of a pixel, then we can consider one proper row and one proper column. Okay, so whatever the orientation of it, so that is called as a pixel. So also we can find out in a various types of distances. X axis कुठे क्रॉस होतो आणि y axis कुठे क्रॉस होतो. Okay, so at that position we can calculate the point value of that particular pixel. Okay, so in point processing we have to study the various types of operations. What is the image negative, what is a contrast stretching, what is a thresholding. Okay, so along with this we have to study 7 to 8 operations so that can be performed on an image. Okay, if we take a one simple example, so have you, okay, so if we observe the slide, and here we can read the various examples. So we can mention here 4 types of example. One is a image negative, other is a contrast stretching, one more is a thresholding, and fourth one is a brightness enhancement. Okay, so when we use any application in our mobile phone, so by using that application we can make a changes. So sometimes we can make a darkness in the image, we can make a brightness in the image, we can color, we can change various types of colors, various types of shades, right? So whatever this type of operation we can perform in our mobile by using a specific app, so that is nothing but the point processing. Okay, so if we convert the, if we change the brightness, that is called as a contrast stretching. Okay, so all these operation we have, we can use in our mobile phone by using a specific app. So that is nothing but the point processing. Okay, so along with this point processing we have to study what is a gray level transformation. So in gray level transformation we have to study the linear transformation, logarithmic transformation, and power law transformation. Okay, so when we study these three concepts, then our idea should be clear. So we have to study these three types of transformation uh, along with the point processing. So the linear transformation, logarithmic transformation, and power law transformation. Okay, so these three transformation can be used in our day-to-day life. So how we can use these three kind of transformation? Here we can find out the application of these three transformation that we have to study in a gray level transformation. Okay, so here we can just discuss what is a linear transformation. So in order to discuss a linear transformation, we can consider one identity transformation. So it consists of x-axis, y-axis, and operator as a t. Okay, so we can consider here pixels values ranges from 0 to 255. Okay, so as we consider the pixel values are 0 to 255, then the size of image should be 256 by 256. Okay, so we can arrange the rows and columns on a x orientation and a y orientation. Okay, and if we apply any transformation, so as we changes the pixel on x-axis, so in same manner the pixel those who are located on y-axis, that can also be changes. So if we consider here x-axis ranges from 0 to 255, and we can take a one point. So if consider we can take a one middle point. So at a middle point we can consider the mid range between 0 to 255. So it might be a 150, and from this point we can draw a one vertical line. So up to this the tangent line of t, we can put a one pot sorry put a one dot, and then we can draw the horizontal line. So at this horizontal line, the value of pixel on y axis also the 150. That means in identity transformation, with the change in input, the output can also be changes in a similar manner. So if we changes from 0 to 150, then the pixel position on y-axis also changes from 0 to 150. So if we changes from 0 to 200, then the pixel position on one y-axis also changes from 0 to 255. So that is nothing but the identity transformation. Okay, so opposite to identity transformation, there is a one linear transformation that is called as a negative transformation. So in negative transformation, so opposite to this, it also having a uh, output pixel. The pixel located on y-axis can be also changes with respect to x-axis. So if we mention this example in case of our electronics, so we have a positive temperature coefficient and negative temperature coefficient, right? So in positive temperature coefficient or negative temperature coefficient, how the there is an effect due to the temperature. So sometimes it may be increasing, sometimes it may be decreasing. So similar concept can be applied in a linear transformation, in a identity transformation, and in a negative transformation. So the concept of this is similar to the positive temperature coefficient and negative temperature coefficient. Okay. So here we can discuss a first type of point processing. Okay. So we have to discuss different types of point processing. So the first type of point processing is a image negative. Okay. So can anyone tell what is a image negative? Any idea regarding image negative? Yes, anyone? Roll number 8. What is the image negative? Roll number 8 is there. Roll number 24. Yes. Do you have any idea what is the image negative? No idea. Okay. The image negative म्हणजे बेसिकली काय? So if we consider a image, आता आपण इमेज मध्ये काय करतो? We can suddenly change in the image. म्हणजे जर पूर्ण इमेज डार्क असेल, ठीक आहे, तर त्या पूर्ण डार्क इमेजला आपण एकदम व्हाईट मध्ये पण कन्वर्ट करू शकतो बाय युझिंग अवर मोबाईल ऑल्सो. ठीक आहे, म्हणजे आपण काय करतो, जर पूर्ण ब्लॅक इमेज असेल तर त्या ब्लॅक इमेजला पूर्ण काय करतो, वी कॅन मेक अ व्हाईट. तर एखादा पूर्ण व्हाईट इमेज असेल, सो वी कॅन ऑल्सो मेक इट एज अ dark. So that is nothing but the image negative. The image negative म्हणजे we have to take the opposite action on our images. जर इमेज पूर्ण डार्क असेल तर त्याला आपण पूर्ण ब्राईट करू शकतो, किंवा पूर्ण ब्राईट असेल सो वी कॅन मेक अ dark. Okay, so I'll show you the some images. So based on this, might be your idea should be clear. Okay, so we have two images. One is called as a original image, and another is called as a negative image. Okay, so now observe these two images and tell me the concept of image negative. So what you understood from this image? So can you able to understood the concept of image negative by observing this image? दोन्ही images सेमच आहेत, सारख्याच आहेत का? Yes, roll number 8. Now define what is the image negative by observing these two images. Okay. Okay, now listen it. So here we can observe the two images. So here is the image of sheep. Okay, and there is a otter. Okay, if we observe carefully, so observe the color of otter. ठीक आहे, मग आता ह्याच्यामध्ये जो काय ऑटरचा कलर आहे तो कसा दिसतोय? इट इज अ डार्क दिसतोय, डार्क आहे, राईट. अँड ऑब्झर्व द राईट हँड साइड इमेज. So the color of water is bright, right? So here we can take the opposite action. Whether we can apply the image negative on any images, then there should be a change in color. Okay, so if we so generally we can take a black and white image. So what are the black part that we converted into white, and what are the white part that is converted into the black? So if we observe the shape, ठीक आहे, आणि जो काही मग शेपचा बॉटम स्ट्रक्चर आहे, सो इट हॅव्हिंग अ ब्लॅक कलर. सो दॅट ब्लॅक कलर कॅन बी चेंज इन टू द व्हाईट कलर. आणि जो काही शेपचा वरचा टॉप पार्ट आहे, सो इट हॅव्हिंग अ व्हाईट कलर, सो दॅट कॅन बी चेंज इन टू द डार्क कलर या ब्लॅक कलर. नाउ अंडरस्टूड इट? What is the image negative? So basically the image negative is we have to take a opposite action. So white might be changed into the black, and black might be changed into the white. Okay, so here also we can take a one image. So it is a this image is captured in one hospital. Okay, so here also we can check the what is the image negative. So observe the first image and second image. Okay, so what are the black part? What is the white part that is converted into white, and what is the white part? Okay, so here we can have a, so here if we observe there are some square boxes on a row. Okay, it consists of some light, it having a white color. So that white color can be changes into the black color. Similarly, if we observe the here monitor, so the screen of monitor is a black color, so that in a image negative the black color can be changed into the white color. So it is a concept of image negative. Okay, so By using this simple diagram, uh, might be our concept should be more clear. Okay, so here what are the black part that is converted into white, and what is the white part that is converted into the black. So in first image, the background of image is a white. So after applying the image negative, the white background is changed into the black. Okay, and what are the black shades? So that black shades can be converted into white, and what are the white shades that can be converted into the black. Now understood it, what is the image negative? Yes. Roll number 22. Okay, so likewise, we have to study the various types of point processing operations. आता हे काही point processing operation आपण study करतोय. So these are the not new to us. So जे आपण मोबाईल मध्ये एखादं application use करून करतो, ठीक आहे. So we can make a black image into the white color into the black. Also we can check the increase the brightness. एखादी इमेज आपण ब्राईट करतो, डार्क करतो, काही कलर त्यामध्ये ऍड करतो. वी कॅन ऑल्सो, जर एखादी इमेज आहे आणि त्या एखाद्या इमेज मध्ये एखादा पर्टिक्युलर पार्ट पण आपण ब्राईट करू शकतो. ठीक आहे. सो दॅट थिंग वी हॅव टू स्टडी इन अ पॉइंट प्रोसेसिंग. ओके, म्हणजे काय आपण वी कॅन यूज इन आवर मोबाईल. सो दॅट नथिंग बट द पॉइंट प्रोसेसिंग, and it is a part of image enhancement. Okay, so likewise we have to study the various types of point processing. So first one is the image negative. So by using image negative, we can take a reverse action. The black thing is colored into white, and white thing is colored into the black. Now how to represent the image negative? Okay, so here is the formula to represent the image negative. So the formula is S equal to L minus 1 minus R. Okay, so it is a S, what is a L minus 1, and it is R. Here we can indicate uh, the L minus 1 is the maximum pixel value, and the small r is the pixel value of image. So that is a, if we consider the 250 by 255 image, sorry, the 256 into 256 image, so it can ranges from 0 to 255. So the 255 nothing but L minus 1. So that is a maximum pixel value. Okay, so if we take the 1024 by 1024, so in this case the maximum pixel value is 1024. So the L minus 1 is a maximum pixel value. Okay, so from that maximum pixel value, we can minus the some pixels. Okay, and that is represented by a R. Okay, so if we consider the 1024 by 1024 and all the pixel having values 1024 by 1024, मग इमेज कशी दिसेल? पूर्ण ब्राईट दिसेल. आणि जर सगळे पिक्सल आपण 0 कन्सिडर केले तर इमेज कशी दिसेल? ब्लॅक दिसेल. Why? So the 0, the black color can be represented with a 0 pixel. Okay, so it is the representation of image negative. So by using this formula, we can represent the image negative, and by using this type of images, we can get the idea what is the concept of image negative. Okay, clear? So here also one more example. So in this, so it is also the example of image negative. So also we can take a gray image and we can apply the image negative. So the black color is changed into the white, and the white color is changed into the black color. Okay, so the second type of operation is contrast stretching. Okay, so that point will be covered in our next lecture. Okay, so in this lecture we can just study the first type of point processing, that is a image negative. So all of you understood it? It is an image negative. Yes.